Okay, so now that we have looked at how we can solve quadratic equations by graphing, we're going to look at our first algebraic method. We're going to solve these using our factoring. So the first step is, very much so like with our graphing, we're going to move everything to one side. So we want it all to be on the left side or the right side and make the other side equal to 0, or the equation to balance out to 0. The second thing we're going to do is we're going to factor out any common factors. The nice thing about this is if it's in an equation form, then I can just divide both sides by whatever the common factor is, and 0 divided by anything is just going to make it 0. So unlike when I have my expressions, then if I am doing this for an equation, I can just cancel out that common factor. Then I need to use my factoring methods that we learned in grade 10 in order to factor down the polynomials. So I could either have a difference of squares, I could have a trinomial type 1 where the a value is 1 and I can do this by inspection. I can do type 2 where the a value is not equal to 1 and I'm going to use decomposition. Or I can factor down if I have a perfect square trinomial, which we've gotten a lot of practice with when we've been doing our completing the squares. So once the quadratic equation is written in its factored form, x minus a or x minus b, reasonably speaking, it could actually be ax minus b or cx minus d, because in this case I just have a coefficient for x, which means that my answer isn't going to be integers, it's going to be some sort of rational number or fraction. Once I've done that, I can make each factor equal to 0 and then solve for x using what is called the zero product rule. The zero product rule states that no matter how many numbers I have that I'm multiplying together, a times b times c times d times etc., in order for them to equal 0, one of those numbers has to equal 0. If any one of them equals 0, no matter what the numbers are, it's still going to multiply together to make 0. So in order for our equation to balance out to 0, one of the factors has to be equal to 0, and that will give me the possible numbers for x that will cancel this out. That is how I found the roots of my equation. So let's take a look at this. For a and b, they're already factored. So for a, I could have two possibilities. I could have the factor on the left, x minus 4, could possibly equal 0, and that would make this equation equal 0. Or I could have the factor on the right, 3 plus 2x could equal 0, which would also make my equation balance out to 0. In this case, x is going to equal 4 when I balance it out. In this case, 2x would equal negative 3, or x would equal negative 3 over 2. Because in either of these cases, it's going to wind up making the multiplication wind up being 0, right? If I said that I had 4 minus 4 times 3 plus 2 times 4 equals 0. Well, 4 minus 4 is just going to be 0. And on this side, I'm going to have 2 times 4 is 8, plus 3 is going to be 11, equals 0. Well, because I'm multiplying the 0 in, it's automatically going to be 0, which means that I know that is correct. So in this case, the two possible values for x are either going to be x is equal to 4 or x is equal to negative 3 over 2. In the second case, I have an x that is outside of the brackets, which means that here, the three things that I'm actually multiplying together are 2x and 5x minus 35. Well, I can divide both sides of this equation by 2. 0 divided by 2, still just 0. 2x and 5x minus 35 divided by 2 is literally just going to cancel out the 2 that exists there. Which means that when I divide both sides by 2, I'm just going to get x and 5x minus 35 is equal to 0. Well, actually, there's a common factor in here as well. I can pull a 5 out. So if I divide this by 5, I divide this by 5, then I can say that x times x minus 7 is going to equal 0 still. I've pulled out the common factor and I have it reduced as much as possible. Here's my two factors. I have x as one factor and I have x minus 7 is going to be another factor. Well, if x is equal to 0, there's one possibility right away. So I can see right away if I have an x outside the brackets, then that's going to be one possibility. If x minus 7 is equal to 0, then x would equal positive 7. And there's my other possibility. So in this case, x can either equal 0 or positive 7. For example 2, I need to actually go through the process to factor and then solve this. So the first thing I'm going to do is I'm going to move everything to one side of the equation. I don't like this negative x squared. I like my x squareds to be positive, so I'm going to move both these things to the left side of the equation. And I'm going to state that x squared plus 5x minus 24 is equal to 0. At this rate, I can say that, well, I have an a value of 1, which means that I can factor this by inspection. I need two numbers that multiply to make 24, or negative 24 as the case may be, but add up to 5. And it would be positive 8 and negative 3. So my two factors are going to be x plus 8 and x minus 3 is equal to 0. Then I'm going to state, well, if x plus 8 equals 0, then x would equal negative 8. There's one factor dealt with. Deal with the other factor. If x minus 3 equals 0, then x is going to equal positive 3, which means that my solutions are when x is equal to negative 8 or positive 3. For the third example, I'm going to start by doing the same process. X squared is already positive, so I'm going to move this constant across because I like dealing with the positive x squareds. And I'm going to say that I have 3x squared minus 6x minus 105 is equal to 0. These all have a common factor of 3. So I'm literally going to divide both sides by 3 or divide every single term by 3, which is going to leave me with x squared minus 2x minus 35 is equal to 0 divided by 3 is still just 0. I can do this by inspection again because I have that a value of 1. I need two numbers that multiply to negative 35 but add up to negative 2, and my numbers are going to be positive 5 or x plus 5 and negative 7 or x minus 7 is equal to 0. Here's my two factors. So I take the first factor. If x plus 5 is equal to 0, then x is going to equal negative 5. If x minus 7 is equal to 0, x would equal positive 7, which means that in this case, x can either equal negative 5 or positive 7 in order to make this equation balance out to 0. Now when it says, can you tell the difference between a quadratic expression, a quadratic equation, and a quadratic function? Well, an expression doesn't have an equal sign. if it doesn't have an equal sign and it doesn't balance out to anything, then anytime I pull out a common factor, then I still need to keep the common factor. I can't do this process that I did up here, dividing both sides of the equation by 3, because I don't have another side of the equation to divide by, which means that if there was a common factor, I would need to leave the common factor on the outside of the equation. Expression. When I do an equation, it balances out to 0. In this case, I could solve. There's going to be, in this case, either 0, 1, or 2 possible values that x could be in order to make this balance out to 0. When I have a function, I have 2 variables, which means that x and y could literally have an infinite number of possible combinations that would make this balance out on both sides. Because it's not just equal to 0, there is not set values for what x can be.